Good morning, guys. One more time. Okay, so I think last time we were talking about something like collection, something like list. We have seen many different features, many different functionalities, how to deal with them, how to create collection, how to add or how to append the values, how to remove the values, how to get them reversed, and so on and so forth. So we have talked about many different things last time. So probably we want to continue further, and we want to start with another collection. But before we start with another type of collection, let us quickly go through maybe a simple program where we can create couple of or we can create an array or a list, and we can add a couple of values there, and we can perform simple operations. And today we have to look at one more thing, that is something called the slicing. So once we are done with it, probably we'll be able to start with the next collection. That's what I was wondering. This is JavaScript, so I was looking for the collection and I was not able to find them. Okay, this is Python, not JavaScript. Here it is. So this is the indexing part. We started yesterday. We already have talked about that yesterday. So let us continue further. To create a quick application, let's revise it and let's talk about something called the slicing. Here we are. I'm in page 1, and we will start writing a very simple function. By the way, you will find the code in your code utility. Just go there, refresh student portal one more time, go to that code section, and you'll be able to find the code there. Okay, so there you are. It's still asking me to do it again. Just give me a sec. Don't want to add it, I want to select this. Okay, maybe this is the one which is having all the packages for me. Yeah, this is the one. Okay, so here we are, and I'm creating a very simple list. Now the list here may be kind of numbers, which is going to have the values like 10, 20, 30, 40, 50. We have seen these functions yesterday. I'm just going to quickly look at them. So I can say numbers.append, and I can add 60 there. So maybe it depends on you whether you want to append. When you append a value, the value will get added inside the collection towards the end of it. So it will be added at the end of the list. This is the standard rule. If you want to add in between, there is another one, something called as an insert. So you can say insert at, let's say, third position and the value equals to 70, whatever, it depends on you. So probably at every single point, I'm going to quickly print the state of that collection. So this is the one, this is 2. Okay, so here we are performing the add, we are performing the insert operation. Now I want to remove the value. So to remove the value, I can say numbers.pop. It will remove the last value. Next, again, when we are performing any operation, I want to simply print the current state. So print that numbers one more time. You see, numbers.pop, I can remove any value in between. So let's say this is 2, for example. I can say again print numbers. And if you can recall, pop is going to remove the last value. Pop2 is going to remove a value at particular index. And if you want to remove a value, not by index, but actually the value, then you can say numbers.remove and the value you want to remove. Let's say I want to remove value 20. So this is how we can do it. Probably it's enough for the first function. Let me quickly run the application. You see here, this is my original state. Then I added 60 towards the end of it, added 70 in between, removed the last value, that is by pop, and then removed second index. Second index is nothing but 0, 1, 2. So 30 is removed. And then I removed the value 20. So 20, it was there earlier. Now it is not there, which means value 20 got removed. Again, all of these things are something like the features, something like the functions available on a list collection. And those functions will deal with the list. Again, if you're talking about the list, just quickly write another function, and let's look at few more functions, revise them quickly, and then we'll continue further. So this is my another collection. I'm going to add this there, and let's add a couple of more in between. 30, let's say 10 one more time, 50, let's say 50, 70, let's say 60, and so on and so forth. So I have a numbers collection again. I want to find out how many times 50 is repeated. So maybe I can say count 50, which is equals to numbers.count, and I can pass 50. This will tell me how many times 50 is repeated. Again, I can print same thing by saying 50 repeated these many times. So count 50 times. That's it. So this is what the count will tell me. If I want to find out, if I want to find out the index of it, probably I can get let's say 50 index or index 50, or let's say index 70, for example, which is equals to, I can say numbers dot index, and I can find the value 70 is index. So maybe I can again say value 70 appears at this particular index. So this is the index 70 index or position, whatever. So this is something we already have seen yesterday. So you can use that count function to see how many times the value got repeated, and you can use the index to see how many times or where that 70 value is present in your collection. Now, other than that, if you want, you can go for numbers dot reverse. Reverse will reverse the actual number. So it's not a good idea to do it. So maybe I can say numbers reverse, which is equals to numbers dot copy. If you can recall, we already talked about this. And then I can say numbers reverse dot reverse. So this is how we can do it. Again, one more time, I'm going to say numbers sorted ascending, which is equals to numbers dot copy. I'll create a copy of it and I'll say number sorted ascending, we can say sort. So that is how we can do it. Similarly, I can go back here and say this is the DSC, the DESC precisely. So this is going to be DESC, and the reverse is equals to true. That's it. So this is how we can get the collection reversed. So I can say this is number reverse. Let's print the collection sorted collection again. Print, let's say number sorted ascending, and one more time print number sorted descending. Let's call this function, get all the functions, all the features, all the methods in one single program. 50 repeated 3 times, we already have seen that. 70 appears at 5th position, very good. This is reverse of that array, reverse of that collection. This is ascending order and this is descending order. Yeah, things are working fine. This is something which we already have seen yesterday, and we already have seen many different examples or how to use them and where to use them. So already talked about them yesterday. Okay. So now we want to continue further and want to go for a few more functionalities. Now to do this, probably I'll leave this function, I'll leave this page as it is. It's a kind of quick revision of it. Now we will start with the next point. The next point is nothing but slicing. Oh, before I go to the slicing, I'll quickly write one more program. This is again a revision, quick revision, so that everyone will be on the same page, and then we'll start from there. So probably I want to go for, say, indexing. Indexing is nothing but the way you are kind of getting the values by index. I think it's better, it's not a good idea to go with this one. It's better I can just go for serial values. So it will be easy for you to imagine what is going to happen. So 60, 70, 80, let's say 90 and 100. Okay. So probably if you can recall, you can say value at 0th position. This is something again we have explored yesterday. This is a quick revision of it. This is 0. Maybe I can just go for the last position. Value at the last position is nothing but this is a len of function 3 minus 1. So basically len of function 3, I'm sorry, len of function 3, what the hell? Len of numbers minus 1. This is going to give me the last value. And probably if I want to go for the negative values or negative index values, I can say the same thing. Let's say first value or value at first position. I can easily say that maybe instead of saying 0th position, I can say that is the first position, which is nothing but again numbers of len of numbers, and that should be minus. Negative len of numbers will give me the final value, the first value. So you can go with the 0 or you can go with minus len of numbers. Both of them will give you the same value. And if you want to go for the last position, you can always say number of numbers of number len of numbers minus 1, or you can simply say minus 1. Both of them are exactly fine. Okay, so let me go back here. Let's say function 3, and probably yes, it gives me the value according to what we have said. The first position, that is 0th position, it's 10, and minus 1 position is also 10. The last position, the len minus numbers, len of number minus 1, and you can say numbers of minus 1, both of them will give you the last value. So this is something what we have explored yesterday. So I said that when you're talking about something like the indexing, in case of Python, indexing can be positive or indexing can be negative. So when you are going for positive values, you will go from left to right, and when you go for negative, you'll come from right to left. So -1, -2, -3, -4, -5, so on and so forth. Actually, in both the direction, I mean, in both the cases, the direction of increasing the values are from left to right. But just for easy to understand, that's the reason, just for the understanding purpose, the 0 will increase on 0 to left to right direction, and -1 will come from right to left direction. So this is something what we have explored yesterday. Now, quick example, Rohit, what you're saying? Can you please explain what key is equals to lambda in this case? Which one you're talking about? I'm trying to sort the list as a case sensitive. List is sort key equals to lambda, blah, blah, blah. Oh yeah, you're talking about a sorting behavior. Now, precisely, if we can use a different mechanism for sorting. Again, I don't want to talk about this right now because this functionality we will talk about sorting the objects. There you will see right now these are the values, so we don't have to worry about them. But when you go for objects, when you go for class, then you will have multiple attributes in your class or class objects. In that time, if you want to sort that particular array of objects, how do you want to sort it? That will be decided by using this key. So just wait for object oriented programming, and after that ask the question again. I'll definitely answer it one more time. Okay, in this case it doesn't matter because by default the sorting will work because all of them are the values. Okay, that is mainly required for going for the actual the object sorting. So there it will be useful. Okay, who's that, Pranav? Please repeat in short. What do you want me to repeat, Pranav? I'm not getting you. Rajendra, line number 54 once more. What that line number 54? This is something what we have explored yesterday. Do you remember yesterday's diagram I talked about? What I'm saying here is this. Just give me a sec. What I'm talking about is this. So if I go back to your the Python 4, here we are. And if I look at the last diagram, the one we were talking about, this one. So if you talk about this diagram, you see that -1 will be the last value and minus length of array will be the first value. So that is what we are doing here. So what is the value here, or how many values we are having here? It seems like we are having 10 values. So basically minus len of numbers is nothing but -10. So basically this is nothing but -5, which is nothing but the length of array. In our case, the length of array or length of list is 10. So -10 will give me the first value. So always remember, minus len of collection will give you the first value and -1 will give you the last value. At the same time, 0 will give the first value and len of collection -1 will give you the last value. So this is positive index. This is the way you can go for that indexing in a positive way, and this is in a negative way. So if you want to go for that, you can also go for negative way. So that is how we can deal with it. Okay. So in this case, probably you might have seen all the features, all the functionalities, all the methods we have seen so far in that collection called as a list. So Sangram, what's your question? What is a list comprehension? Wait, coming. There is a list comprehension. There is a map. There is a filter. Yes, everything is coming. I can't just talk everything about talk about every single thing in one session. Yes, it's coming, Sangram. It's pretty much fun using list comprehension. This is one of my favorite points in Python. I love Python because one of the features is the list comprehension, and it's pretty simple. We'll talk about this right after we are done with the collection. Okay, just hold your excitement and you will get the answer. Akshata, what's the use of negative indexing? Right now, don't ask about the use case because the use case you will find in different packages. For example, what's the main use of it? We'll talk about this in other packages like NumPy and Pandas. So there you will see why negative indexing can be used. Right now, see what is the feature I'm talking about. Later, anyways, we will talk about different packages. There you will see what exactly the use case where you have to use a negative indexing. Okay. Anyways, so this is a quick revision of what we have done so yesterday. So now we'll continue further and we'll talk about the next feature. The next feature is called as a slicing. Now, what do you mean by slicing and how it can be used? Again, I'm sorry. It is again a very simple feature of Python, which is kind of pretty intuitive. Now, when I say it's a slicing, first, let me tell you, if the slicing feature is not available in Python, what problem you will face and what exactly slicing or what problem slicing generally solves. So let me just come back here and say this is again a numbers collection. So let's say I'm having values 10, 20, 30, 40, 50. Let's add another 60, 70, 80, 90, and 100. Okay, so now I have 10 values. My requirement here is I want to get the values from 1, 2, 3, and 4. See, this is what the portion of list I want to get. How do I get 30 to 60 values? To get the 30 to 60 values, I'm going to say numbers, let's say, I'm going to call it as a slice. Slice means I'm not considering the entire collection, entire list. I want to get the portion of that particular list. Portion of a list is called as a slice. So for example, I want to extract only these values, 30, 40, 50, and 60. How do I do that? To do this, I'm going to come back here and say number slice is equals to an empty list. Then I can simply start running a for loop. So I can say for, of course, when you want to go for this to this, we'll have to use the index mechanism. I can't just talk about the values. So for example, it's 0, 1, 2, 3, 4, and 5. So I need 2 to 5 values. How do I do this? Very simple. You can come back here and say index positions or simply positions that I want to extract. You can come back here and you can say this is 2, 3, 4, and 5. This is what I'm going to extract. So probably from index in positions, and then you can say number slice dot append. Append is the feature, append is the method we already have seen yesterday. So I'm going to extract that value at that particular index and want to add that inside that number slice. So precisely, I'm going at the second position, getting the value, adding it to this one, getting the third value, adding it to the fourth value, adding it to this, and fifth value, adding it to this. Now, once we are done with this, I'm going to come back and just print the number slice and see what I get there. So this is my function one. Let me make a call to this. And yes, I got the portion of that list. So to get the portion of a list and precisely sequential portion of a list, we have to go from a particular position to a particular position. So here I would say this is a sequential slice. And when I say sequential, this is the lower bound, or maybe I can say this is the start, which is 2, and this is the stop, which is 5. So basically, I want to start from 2 and want to stop at 5. To be very precise, when you talk about the feature we are going to see in a moment, there you have to add 1 into stop because the upper bound will never be included in that slice. So in this case, what I'm trying to show you here is like how to extract the values, existing values from your collection. Now here, the things are like we are talking about a sequential access, and a sequential is nothing but 2, 3, 4, 5. They are in sequence right now. Fine, I'm okay with it. Now, if I want to achieve exactly same thing, see what Python says. Python says, see, what you're trying to achieve here is you're trying to go from sequence like 1 to 2, 2 to 5, for example. So instead of you going for the sequence, or instead of you creating these hard-coded positions, you might say something like this as well. That will also give you exactly same meaning. So I could call a function called as a range, if you can recall, and I can pass range starting from 2. If you can recall again, we can't use 5, we should go for 6, because in that case, I can use that range starting from 2 to 6, 6 minus 1, 5. So it will always start from 2 and it will go up to 5. So 2 to 5 can be replaced with this range. Again, before I start with the second function, let me prove the fact that it is also going to give you exact same behavior. So the first thing is like you have to create one more collection. You use that collection and then you run a for loop on this, use that index and then get the value at that particular index. So this is a general logic you can implement in other languages as well. Irrespective of language, this is a common logic to extract some values from your collection. It's very simple. But now you are in Python. So Python says, don't run a for loop. Don't add more efforts into it. Just you focus on your functionality, you focus on your features instead of diving into these details. So Python already has solved this problem. Python knows many a times it's been observed that people generally need some sequential access to few files or few values in your collection. And if it is the case, Python has inbuilt feature which is called as a slicing. So this feature is called as a slicing. Now, what do you mean by slicing? Slicing means getting the values sequentially from your array or from your list or simply from your collection. So for example, I want to get the values from 2 to 5. So I could do something like this, like position equals to this, or I could call that range function and get the position, and then I have to run a for loop. But using slicing feature, see how simple is that? Using slicing feature, you can directly say numbers, I don't have that collection anymore. Let me just copy and paste it. So this is the slicing feature and see what you can do here. So you can say numbers using the index position or using the subscript, you again want to go from 2 to 5. So basically 0, 1, 2, 3, 4, and 5. This is what you want to do. Whatever parameters you were passing here to the range, just pass them here. It's 2 and 6. Now, last time when I passed them to the range, I used a comma. Instead of using comma, just put a colon. That's it. This is called as a slicing feature. And believe me, it's very, very simple and very intuitive. So basically, when you are in Python, you don't have to put more efforts into the basic things. Those basic things are by default provided by Python. So when I say run, you see, I'm getting exact same numbers. Now, when I say exact same numbers, it's like starting from 2 and going to almost like 5. So it's 2, 3, 4, and 5. That's it. So basically, you say this way, or you say this way, or you say this way. Ultimately, you are going to get the values like 30, 40, 50, 60. This is called as a slicing feature in case of Python. I hope you can see how simple is it. So you can say 2 to 6, that will give me the values starting from 2 up to 6. Let's take one more example. I'm going to come back here and I want to get the values like 50 to 90. So how do I get the values from 50 to 90? Again, it's 0, 1, 2, 3, 4. So starting from 4, 5, 6, 7, 8. So actually, I want to go from 4 to 8. So if I want to, then I can say something like numbers 4 to 8. I'm sorry, 4 to 8. But wait a second. You have to add 1 into the upper bound. So if I want to go to 8, then I'll have to add 1 to it, and that will be kind of 4 to 9. So it will start from 4 and it will go to 8, the position. So probably I'll just go back here. I'll say this is a 4, 5, 6, 7, 8. That's it. 9 will be not accepted, or 9 will be kind of discarded here, or 9 will be not considered here. You see, 4, 5, 6, 7, 8. That's how we are getting the values from our collection. Now, the feature I'm talking about, slicing, is applicable on both the one which we are talking about here, that's a list, and the one we want to talk about after this is called as a tuple. It's available for both of them. Okay. So yeah, a slice feature is equal to between, you can say so. Instead of saying the slicing, you can say give me the values between 2 to 6 or 2 to 4 to 9. Yeah, that is also fine. So Shripati, you can say so. Fine. So now when you're talking about the slicing feature will give you an option of getting only the slice, only the portion of your entire collection. So if you want to do, if you want to achieve something like this, you can go for that. And believe me, it's very popular and it's very frequently used, at least in a programs like data processing or data analysis or data analytics. There you want to retrieve the portion of your data. This is going to be useful. So this feature is called as a slicing feature. Now imagine that you want to get the values, let's say from 40 to 100. So this is what I'm looking for. Watch here and see what are the different shortcuts available in slicing. So I want to start from 40 and I want to go till 100. So how do we do this? Probably what I'm going to do here is I'm going to say numbers. See, I want to start from 40. 40 means it's 0, 1, 2, 3. So we'll have to start from 3. And till which value should I go for? So 3, that's 4, 5, 6, 7, 8, 9. This is the 9th position. But again, we'll have to add 1 into it. So it's 3 to 10. So 3 to 10 means we want to get the values starting from 40 to 100. So this is what the answer will be. I'll just put the answer here. So you will see whether it is right or wrong. So this is the answer that I'm looking for. And when I say run, probably you see we are getting the same values 40 to 100. That's it. This is the way we can get the values. Now, when you already know that you're starting from 40 and you want to go to the last value in your collection, then you can achieve the same thing by using one more different approach. You can say, hey, I want to get all the values starting from 3 up to the last value. So when I say up to the last value, you don't have to specify the upper position or maybe the upper bound there. So probably I can say this is numbers, and numbers is like, just getting, just starting with value 3 or just starting with position 3, and I'm reaching to the end of the list. So to say end of the list, you don't have to supply the upper bound here. So if you are not specifying the upper bound, means it is going to consider last value as your upper bound. And when I say run, you see in both the cases, I got exactly same result. So remember, when the right side is missing or the upper bound is missing, that simply means you want to go to the last value. That's what you have to understand. Now let's look at the other example. Say I want to get the values like this. Let me just look at the collection one more time. And I want to get the values like 10 to 40 or 10 to 50, for example. So this is what I'm looking for. So if I'm looking for 10 to 50, that means it's a 0, 1, 2, 3, 4. So if it is like 0 to 5, I have to say, because 4 means we'll have to add 1 into it. And this is 1 to 5. I'm sorry, not 1, it's 0 to 5. So when I say 0 to 5, I'll get the values like 10 to 50, 1, 2, 3, 4, 5, absolutely. But if you want to start anyways from 0, so what Python says, you can take a shortcut. You don't have to say a 0 there. So you can simply skip the left hand side and just say that I want to go from 0 to 5 by skipping 0. So again, if the right side is missing, that means you want to go to the last value. And if the left side is missing, that means you want to start from the 0th position. So that is how you can get it. Naturally, you can get all the values by saying something like this. So again, I just go back here and say, this is what I'm looking for. I want to get the values, rather all values here. So this is what I'm looking for. So if I'm looking for all the values, again, I could say something like numbers starting from 0 to 10. 0 being the first position, 10 being the last position. And if it is the case, I'll get all the values there, starting from 10 to 100. But again, Python says like if you want to get all the values, then the better option is don't specify the upper bound because it will go to the last value, and don't specify the lower bound because it will always start from 0th position. So just adding a colon in between will give me all the values there. So probably when I say run, you will see that, see, I'm getting all the values there. So you can either say this or this, that will give me exact same result. By the way, this will also give me exact same result. So even if I say nothing here, or even if I say nothing here, all these conditions will give me exact same result. I hope you can understand the conditions here. 0 to 10, where I'm specifying the lower and upper bound, or start and stop. Here I'm specifying start but not specifying stop, means it will always go back to the last value in the collection. In the next example, I'm not specifying the start value, but I'm specifying the stop value. If I do not have the start position, by default it will start from 0. And in the last case, I do not have the start position and the stop position, means by default it will start from 0, and by default it will go to the last value in the collection. What you see here is called as a slicing feature in Python. I hope you can understand. It's very simple, it's very intuitive, and probably it's very useful when you are going to process a huge amount of data. So you can take out some data randomly, for example, to study what type of data you are looking at. And maybe this is very useful when you are processing or when you are analyzing the data. So that's the reason why I said like it is very popular it's very popular in data science, or it is very popular when you are processing the data, or data engineering precisely. Okay, Adesh, your question, how to divide one list into two? What are the different ways? There are different, like what we said earlier, you can run your for loop, you can put your own logic, you can use slicing, and you can also do that. And there are a bunch of other ways to do this one. I mean, in this case, I can show you at least two of them. Either you can run your own for loop, or you can go for slicing. Maybe if you're going for something like a NumPy and something like a pandas, there are a couple of more ways where we can just split the list into two portions. So we'll talk about them eventually later in NumPy and pandas, because anyways this is a pandas and NumPy related question, so I'll talk about that there. Okay, one more time there. Prashant, what if there are more than 1,000 numbers? How do we slice? How do we predict the index? It's not predicting the index. It's like you have to know the index in order to go for slicing. Haven't you seen that? When you talk about the slicing, the very first thing that you should start is the start position, and the next one is a stop position or the last position. So unless you know the positions, you cannot go for slicing feature. So slicing feature is useful only when you know, I want to get the values from this to this position. So unless you know the starting position and the ending position, you cannot go for slicing. So hopefully, Prashant, that answers your question. You have to know the position before you start something like a slicing feature. Okay. Okay, another question quickly, Adesh. Okay, fine. That's thank for confirmation. Shubham, your question. Does slicing returns a different list? Absolutely. And that's a reason why I'm adding that into the print. So print something means This is returning a separate list. It's not modifying this existing one. It is returning a new list. So basically slicing literally takes the positions from 2 to 6 or 2 to 5 precisely in this case, and it creates a separate collection and then it returns it here. Exactly what I did here, Python is doing it on behalf of me. So Python is saying like, why are you wasting your time into this one? Let me do it. I already have done that. All you have to do here is just use a specific format, and I will do what exactly you are looking for. So again, yes, absolutely right. It has to be again sequential numbers, and again when you're using sequential numbers, it is by default going to return a separate collection. It does not modify the original list. It's not like reverse, it's not like sort. It does not modify the original collection, or it's not in places slicing. It is going to return a new collection there. Okay. Okay, the different list. Girish, what's your question? Still executes the print numbers 0 to 15. Yes. Now this is a kind of not required to talk about it, but anyways, you said so. So I'll talk about this anyways. So when I say 0 to 10, probably you can say that in 0 to 10, I know my 0 means it's its first position, and 10 minus 1, 9 is the last position. But if I say 0 and 100, I know there is no value after 10. Let me give it a try, and you will surprise. Python is smart enough to know where to stop. Where to stop in a sense, it knows the values are starting from 0th position and the last value is 9. So even if you specify something which is way greater than your upper bound, it is not going to work. I mean, it's not going to continue with this, or it's not going to give you any exception. The Python is smart enough. It knows the values are maximum 10 in that collection. So it stops exactly on position number 9. So after that, even if you are specifying 100, you are still going to get only 10 values starting from 0 to 100. That's it. Okay. So probably Girish, that answers your question. Utpal, can we use the AND operator in slicing? Not in slicing, but in filtering. So again, wait, filtering, we'll talk about it later. There you will see how to do that filtering part. Okay. So this is not filtering, this is slicing. There is a difference between filtering and slicing. Filtering means you want to get the values between this and this, or you want to get the values which are satisfying one and the second rule, or one or the second rule. In that case, that is called as a filtering, not slicing. Okay. Priyanka, your question, can we get all the values by numbers or numbers? Exactly. I said that this can be done again by using one more ways. You don't have to specify this, or you can simply say numbers. Again, you are going to get all the values here. Absolutely right. Yes. Akash, sorry to interrupt, the videos is lagging your audio and they are not synced. Can you please check? I don't think so, because yeah, I am in sync. Maybe it's your internet connection. Just take a look at it, or maybe see if there is any problem from your side. Okay, I don't have any problem from my side. Okay, so might be that's a internet connection. Santosh, your question, let's say there is a list with 2 indexes with value 50. Is there any function to get the second index position? Of course, yes, we talked about it. Do you remember when you talk about the index position, there you have to start, there you can pass the starting position. So there, instead of saying the first position, you can say first plus 1. And I mean, first in the sense, wherever is the first position, you know, in the array or in that list, plus 1 will always give the second position. So Santosh, I would request you to look at yesterday's video or yesterday's code. You will definitely get what you're looking for. Okay. Shubham, your question, is it a good practice to use a new variable and then do the slicing? Not at all. Slicing will not require any special variable or any special copy of it, because slicing itself will create a copy of it. Now, a copy is required in case of in-place editing or in-place modification. There are two functions we already have seen last time. One was sorting and the other one was reverse. Both of them were modifying the original collections, and that is the reason why it's a good practice. So it's a best practice that you have to create a new copy and then perform these operations. But here we don't have to. Okay, so I think that's good. Okay, Rajendra, can we copy slides list into other lists? We don't have to. You can, but it's not required, because it ultimately returns a new list. So what you are going to achieve is by default achieved by Python. You don't have to do that. Okay. Aniket, line number 50, line number 50, line number 50. Where are you? Here it is. Line number 50 means where you are not specifying the value on the left hand side. It will by default consider this as 0 as a starting point. and this will consider this as, I mean, if the last value or the right value is missing, it is going to consider that value as the last value in your collection. So in my collection, ninth position is the last value. So precisely speaking, when you're not having the last left value, it will start from 0. When you're not having the right value, it will go towards the end of it. So it will start from 0, it will go to the end of the list. I hope that answers your question, Aniket. Okay. Okay, a couple of questions and then we'll have to go to the next point, guys. Okay, Amrendra, how can we get the values to the odd index only? Exactly, I knew it. You you are asking the questions because what exactly I mean, what exactly you are looking for is what exactly I want to show here, because this is not the end of the story. This is the next point to it. See, anyways, even if you wouldn't have asked a question, I would have already shown you. But thanks for asking that question, by the way, Amrendra. Exactly what you're looking for is what I'm going to show you here. Imagine that I'm getting all the values here. So probably if someone is asking me, get the values on, let's say, even positions. How do I do that? Now to get on the even positions, probably we'll have to start with this. Again, this is the logic without using slicing. So probably all I'm going to do here is, I'm going to say another collection, let's say numbers underscore even, and then I can run a for loop. Again, for that, we'll have to say positions, which is equals to range starting from 0 up to the len of numbers. Then I can go here and say for index in positions, and I want to get only values at the even positions. In a sense, if index %2 is equals to 0, I want to check if the index is even, not the value even, but the index is even. So get the value only at even position. Okay, so how do you do that? You already are checking here if the index position is even or not. If it is even, then you can say numbers even, which is going to get appended to this. So append, and what's that? Numbers. That's our collection name index. That's how we will get it. I mean, we will get all the values on even positions. So let me just go back here, call numbers even, print that function, or call that function and print the values. And yes, I see it's 10, 30, 50, 70, 90. 10 is nothing but on the 0th position. 0, 1 is skipped because it's not even, it's odd. This is 2, sorry, this is 3 because it's, I'm sorry, it's 0, 1, 2. This is 2 means it's even. 3 is skipped, 4, which is even. And that's how we are getting the values. Now, if you want to do something like this, you are taking too much of time to run a for loop to add a logic. Haha, look at that. This is the simplest example. So probably I can go back here and take an advantage of slicing. So when you talk about the slicing, I just showed you only one thing, or I just showed you only the start position and the last position or the stop position, but there is more to it. So probably I can come back here and say print. What I want to achieve here is like values at even position. So how do I do that? Now to do this, first understand, like when you are using that slicing behavior, I hope you can recall, if I say 0 to 10, by default, it will start from 0 and it will go to 10. So precisely speaking, when I say run, I'm getting all the values here. I'm getting all the values because when you say 0 to 10, it will start from 0. Now after 0, it will go to 1. After 1, it will go to 2. After 2, it is going to go to 3, and so on and so forth up to position 9. Now, when you talk about it is going from first 0 to first or first to second, it is doing it because by default, the step count is equals to 1. Step count is nothing but what is the next step you want to go to. So precisely speaking, again, there is one more colon and there is one more 1, which is by default hidden or by default considered there. This is called as the start position. This is called as the stop position, and this is called as the step count. So step count is by default 1, and that is the reason it is going to start from 0 and is always going to increment it by 1. So 0 plus 1, 1, 0, 1 plus 1, 2, 2 plus 1, 3, so on and so forth up to 9th position. Now, when you want to get values only on the even position, which means I want to start from 0, but I don't want to go to the first value. I want to jump to the second value. From here, I want to jump to the 4th value. From here, I want to jump to the 6th value, and so on and so forth. So to do this, all we are going to do here is 0 colon 10 colon 2. 0 colon 10 means it is going to start from 0. 10 means it is going to end at the value 10. And probably when I say 2, it is going to calculate the next value by adding 2 to the previous value. So the previous value or the default value is 0, which is this. The next value will be calculated by adding 2 into it. So 0 plus 2, 2. So 0, 1, 2. It is going to pick this value up. Then again 2, it's going to pick this value up. Then again 2, it's going to pick this value up. It is going to pick this value up. And ultimately, see, you are going to get the values only on the even positions. See how simple is that? So probably when you're talking about something like getting the values at even positions, it's very simple. All we are doing here is you can start from 0, you can add 2 to it, and this is how you can get the values from even position. But now check this out. If I ask you to give me the values at odd position, can someone try quickly and tell me how can we achieve it? How can we get the values at odd positions? How should I do it? Any guess? How should I get the values at odd position? Absolutely. To start with the odd position, you should not start with 0. You should start with 1, because 1 is the first odd position. That's it. You solve it. All we have to say here is change that 0 to 1 and you will get the values on the odd positions. Okay, so here I can say this is 1, this is 3, this is 5, this is 7, and this is 9th. And yes, I can see that it's 1, 3, 5, 7, and 9. This is exactly what we were looking for. So using this slicing has its own advantages. All we are doing here is you are using the start position, stop position, and you are using the step count. Now, how do you want to achieve it? It's up to you. But you can play with the play with these values, and then probably you can get all the values in a particular sequence. Now, anyways, when you are talking about these two, like even position, odd positions, I know I'm going to start from 0 here. I don't have to supply anything there. And because I know that I want to go to the last value, I don't even have to supply that as well. So this is again going to give me exact same result, going to give me the values at even positions. The same is true for odd position as well. So probably, yes, definitely I'll have to start with 1, because if I don't start that 1, it is by default going to start from 0. So 1 is required. But again, you don't have to go for the upper bound or the stop count, because stop will always go to the last value if you don't supply 1. So if I say run, you see by default both of them are giving me the exact same result. So this is how we are getting the slicing done. And when you're talking about the slicing, there are 3 things. One is called as the start count, second is called as a stop count, and the third one is called as the step count. So step count will decide how to get the next value or how to get the next position. So it will start from 0 plus 2 plus 2 plus 2 plus 2. It is going to start from 1 plus 2 plus 2 plus 2 plus 2. So that's how it is going to do it. Okay. So this is called as a stop count. So probably if you just go back to your so-called notes, I think I mentioned that here. If I'm not, then I'll have to talk about it. This is the slice position. Here it is. So if you look at the slicing, you can see that it is a collection, the one which you are using there. And right inside this is the start position, stop position, and the step count. So start is where you are going to start. Stop is where you are going to stop, -1, of course. And step is the one where how you calculate the next value. So this is how we can do it. I already have mentioned this. Stop must be greater than start. Naturally, this is logical. Both of them are optional. If you don't specify the left side or you don't specify start, by default it's going to start from 0. And if you do not specify stop, if the stop is missing, it is by default going to stop at the last value. So this is something that you can do with the slicing. I hope you can understand that. Slicing will give me all the values, maybe all the values at a particular position. The position will depend on the problem you are solving, but the you can say the condition or maybe the syntax is pretty simple here, and this syntax is going to give you a chance to get the sequential values from your collection. So this is how slicing works. I hope you can understand that. Now, one more quick example of it. This is a kind of a trick we generally use. We don't have to, but if you know one more functionality. But anyways, that's a quickest example. So I'm going to do it in this way. By the way, if I specify nothing, so if I say colon, can you tell me what exactly do you mean by that? If I say colon, what is colon? Here, if there is nothing, that means it will start from 0. If there is nothing at this position, at the second position, that means it is going to go to the last value. And if there is nothing at the step count, that simply means it is going to add 1 to it. So this is exactly this. So you may say 0, 10, and 1. So it is exactly similar to 0, 10, and 1. You don't have to say anything there. You can say colon, and this is how you can do it. Okay. Now watch this. I think you can understand that quickly because you already have done that. I'm going to start from 0. I'm going to start, I'm going to go to the last value 10. And instead of saying 1, I'll say -1. Can you tell me what do you mean by -1 here? I hope you can understand quickly. Yes, what do you mean by -1? Exactly, you're going to go in the reverse order. So this is another way you can say getting the reverse values. This time we are not modifying the original collection. If you can recall, yesterday we talked about the reverse method, and reverse method modifies the collection. This is not going to modify your original collection. It is going to create another collection and will give you the values in the reverse order. Check this out. So this is like a reverse the values. And if I just go back and say print, you see all of the values are kind of reversed. So this is how you can get reverse of your collection. So probably it is going to start from 0, -1, -2, -3, -4, -5, -6, and it knows where to stop, because I hope you remember I mentioned this. The first value is always minus length of your collection. So that is how it can be done. I hope you can understand that. So probably this is, the feature is called as a slicing, and this feature is more or less required when you are processing the data. So in data processing, in data analysis, and in data analytics, it's frequently used. So remember that it will help you to solve a couple of problems in NumPy and pandas. So we'll explore those problems later, but right now this is the functionality that you should remember that you should use. Parag, can we use copy of one list into another using slicing? Can we copy one list into another? I'm not exactly getting your point, because if you want to get the copy, then you don't have to go for slicing. You can just use the copy and it will by default do what exactly you are looking for. If you insist, then yeah, you can do it. It's like maybe I can say numbers underscore 1, which is equals to numbers of colon colon, or numbers of colon. That's it. So there are a couple of ways to do it. This is one of them. This is another one which we already have seen yesterday, and this is the one which is preferred rather. This is copy. This is faster than this, and probably another way quickly. So this is one more way. You can say this. Sorry. You can say this one here. So you can say numbers dot copy, or numbers colon, or numbers colon colon. So all of them will give you a copy of your numbers. So copy of numbers collection, or numbers list, better. So I hope that answers your question, Parag. Okay, so this is one of the ways to do it. If you want to copy only even index, so you don't have to, actually speaking, when you're talking about this one. Oh, I think many of you are a little bit confused when I say print here. Guys, when I say print here, that means it is by default returning a collection. For example, if you want to go for only positive values, if I just grab this here and say, let me just go back here and create a separate collection out of it. I'll say def, that's function 5, function 5. And if I say this is the numbers underscore even, this is how you can get it. So basically it always returns a new collection for you. You don't have to copy, or you don't have to go for maybe using the same values again. So all we have to do here is numbers even is equals to this one. So it is by default going to give you the new collection with values at even positions. So you don't have to do anything for that. And that's a reason, because it is going to create a new collection. That's a reason why I was using the print statement with them. What the hell? I didn't print that. Okay. So let me just go back here and say print numbers even. So when I say run, this is what you are going to get. So by default, it is going to return a new collection. So you don't have to do anything extra for achieving something like this. Okay. Yes, Prashant tried with print 0, -1, -1, and output is this one. It's okay. Your Python is smart enough, So Python knows when you are doing, or when you are adding the code there, Python knows where to stop and where to end. That's the reason it works. Okay, so now like what and how we are going there. So probably that we are using the slicing feature here for performing all the slicing features. Slicing in a sense, getting the slice or getting the portion of your entire collection. All of these examples I already have given you in the notes, so you can take a look at them, and probably you will get to know like what exactly they are doing. So if you are looking at the notes, you will see all of these examples there. Anyways, I hope we are done with that list collection. Now, very important point about the list collection. I already have mentioned this here in your so-called notes. And if not, then I'll have to add this line. I hope I must have already added that. So when you talk about the list has a couple of features. Number one, list is something called as a mutable. Now, when I say mutable simply means once created, it can be modified. And that's the reason I hope you can recall the function or the method like sort or the method like reverse. All of them can modify your existing collection. Even append, remove, all of these methods can also modify your collection or add a new value into it or remove an existing value from your collection. It is possible for us to do it because list is called as a mutable collection. So mutable collection simply means the collection which can be modified at the runtime. Hopefully you might have seen that in another languages like C or C++, when you create an array, once created, you never can modify it. But this is not like it. It is a little bit different. You see here, when you are using square bracket and if you're creating a list, then probably you can modify that list at runtime. You can add a new value, you can accept some values from users and you can put them in your existing collection or do anything, whatever you want to do with the list. So the very important feature of a list is it's a mutable collection. Mutable is something that can be modified, that can change its state. That is called as a mutable. Another one, list is slower than tuple. We'll talk about, or we'll explore that in a moment. That another feature I want to talk about here is allows the duplicate values. You already have seen that last time. That's the reason why we are having that index feature or the index method. The index method will tell you like what is the position or the first position of that value, or the count method is going to tell you like how many times the value is getting repeated. So these methods are there. That simply means your list can accept duplicate values. Now, why am I talking about duplicate values here? I'm talking about duplicate values because later, once we are done with the next collection tuple, we have to talk about another collection called as a set. Set is the collection of unique values, whereas list is a mutable, fine, but it also, you can think of it as, it is also a kind of a collection where the duplicate values are allowed. I hope that makes sense, okay? Okay, what's the question here, Praneeth? Tried that, two squares, lambda. Wait, Praneeth, wait for this. There is a difference between what you are doing here and what you are achieving here. That is wrong value, or there is a wrong way to do it. Praneeth, hold for a minute or two. Once we are done with this, I'm going to talk about something else, a map and filter. There you will get your answer, okay? Nikita, your question. So we don't have this notes. How is it possible? I already have shared that. And if you have not received it, not a big deal. Today, I will share them one more time. Okay. Not a big deal. Who's that, Nikita? I'll share the notes one more time today. Anyways, I have to because I modified a couple of things there. So I'll share them one more time. Okay. Where can you find the notes? The notes are there in your Git repository. By the way, Nikita and Rohit, if you already have got the Git repository, you can go to the notes directory and there I already have shared these notes. If not, tell me, anyways, I'll share it today one more time, okay? How list can be const so that we cannot modify it. Adesh, I don't know how you can read my mind because the very next point is called as the tuple, and the tuple is like a list which is not going to get modified at the runtime. So what you are looking for, Praneeth, who's that? Adesh, sorry, my bad. So what you're looking for, Adesh, is exactly called as a tuple in Python. So that's what I was explaining actually. So when you talk about the list can be modified because list is mutable collection. And when it is a mutable collection, you can modify it, you can change its state, you can add value, you can remove value, you can resort the values, you can reverse the values, you can pretty much do anything with it. But there are many situations and there are many scenarios where you don't want to modify the collection. See, in Python, list is mutable, but with a cost. In a sense, when you are doing something like a mutability or when you are achieving mutability, then you have to keep some memory free or some memory always with you, so that if user is going to add some values, you should always create a room for it. So when you are doing something like this, the mutable objects, irrespective of any programming language, mutable objects or the mutable values are always costlier from the memory point of view, from handling point of view. And that is the reason when you are in any language, if you want to make your application performant, or if you want to increase the performance of your application, then consider this scenario, consider this statement. Always prefer immutable objects. It's not only Python, in all languages, if you want to achieve better performance, you always should prefer using the constant values, or you can say immutable values. Values cannot be changed, are called as immutable, simply like a constant values. Okay, let me show you an example of it. So see what exactly do you mean by a collection which cannot be modified at runtime. Till now, the list we were using earlier that we could modify them at runtime. But now see this. I'm going to call this as a function 1, and I'm still going to go back here and say numbers, which is equals to 10, 20, 30, 40, and 50. Watch what I'm trying to show you. 40 and 50. What is it? This is a list. Let me just print that list here quickly. This is numbers, which is equals to numbers, and at the same time, I want to go for type is equals to, again, the type of list, or the type of numbers. Sorry, my bad. Type of numbers. Okay. So basically, when you are talking about this numbers, you can say numbers.append. You can say numbers.remove. You can say numbers.sort. You can say numbers.reverse. All of these methods exist simply because this is a mutable collection. Mutable means it can be modified at runtime. But I don't want to. If I don't want to, then convert this list into something called as a tuple. Now, few people pronounce it as a tuple and few people pronounce it as a tuple. Depends on which country you are coming from. So probably I'm going to pronounce it as a tuple. If you are, if you want, you can go for tuple as well. Again, it all depends on you. I'm going to call it as a tuple. So this is a tuple, and this tuple is going to be created by using a very, very, very simple syntax. I'm going to show you one more time later, but right now I'm just going to call this as a list. I'll make this as a list, and I'll make this as a tuple and tuple. So how do you create a tuple? If you want to create a tuple, all we have to do here is just remove that square bracket and put parentheses. That's it. What you're going to get here is a tuple. So let me just come back, call this function. First, let me show you what we are getting here is a tuple. And yes, precisely, because we started with the square bracket, we got this as a list. And because we used parentheses to put all these values, to collect all these values, I'm getting something called as a tuple. So this is the tuple and this is the list. Always remember, when you are going for a mutable object, prefer list. And if you know the values are not going to change, then always prefer using a tuple. So what is a tuple? A tuple is a collection where, let me just show you here, where, let me say numbers tuple dot, let's say append, the value is missing. I'm sorry, the method is missing. Let's try remove. Oh, the method is missing. Let's try pop, method is missing. Let's try insert, method is missing. Let's try sort, not available. Let me try reverse, not available. You see, all of these methods are missing on tuple simply because tuple is immutable. Immutable means it cannot be changed after you add or after you create that tuple. So after you create that tuple here, probably you can see this cannot be changed. This can be changed, but this cannot be changed because this is a tuple. So that's the only difference between a tuple and a list. A list is always a mutable, while tuple is a immutable. Immutable means once created, tuple cannot be modified. It's a kind of a read only. And when I say read only, that means you cannot add any new value. You cannot remove any value at runtime. So that is the reason why tuple exists. So if you want to achieve something like this, you should go for a tuple. And if you know programming, I hope I mentioned this last time as well, but if you know programming, you know that immutable objects are always faster than mutable objects. And that's how the next statement is coming here. Tuple is always faster than list. It's not the tuple, it's not the list. It's a immutability versus mutability. Immutable is always faster than mutable. And again, it's a best practices, one of the best practices. It doesn't matter whether you are going to be a Python developer or not, but irrespective of it, any language which you are using right now, it can be a Swift, it can be a Java, it can be JavaScript, it can be pretty much anything. Always prefer using constant values, always prefer using immutable values. So that is how we can achieve a better performance in any programming language. So right now you see here, tuple is kind of immutable list. Rest of the things, rest of the story is exactly same. Now, before we talk about the other things, let me create another function called as function2, and let me show you what I showed you earlier. So probably this is what I showed you earlier. I'm going to show you that quickly, and then we'll come back to the tuple. Do you remember how to create an empty list? So probably this is an empty list. To create an empty list, I'm going to say list1, which is equals to a square bracket, or maybe I can say list2, which is equal to a list. So this is going to be an empty list. So probably I'll say that this is F. I'll say this is a list1, which is equals to list1. I know it's an empty list, but I just want to make sure that you are getting the point. So this is again type of list1. Okay, this is again an empty list. So let me put it here, and let me print this and see whether it is a empty list or not. It is an empty list, we know that. One more, what we have seen last time is this, and a list with one value. Only one value. You know how it can be done? You can easily add that by using a list function, or you can add a value like this. This is a list 3, for example. This is a list 3. This is a list 3. This is the list 3 in a sense. This is a list with only one value, you know. So this is the way you can do it. Very, very, very simple. Now on the similar basis, I want to go for comparing that list with tuple. So to compare it with tuple, I can say this is the tuple, which is an empty. I know it is useless. In the real world, you don't have to create a empty tuple, or you cannot do anything with that empty tuple. Because even if you are creating an empty tuple, it's pretty much useless. You will not be able to do anything with that tuple, because tuple once created, you cannot modify it. It's useless, but it is a syntax that I want to show you here. It's a little bit different comparing with the other languages. That's a reason why I'm showing you that example here. See this. I'm going to call it as a tuple1, which can be created by using parentheses, as simple as that. Again, I'll call it as or I'll print it here by saying this is a tuple underscore 1, which is equals to tuple1. At the same time, I'm going to print the type of it like what we already have done earlier. I'm going to call it as a type of tuple1. That's it. I want to create a tuple1, I want to create an empty tuple by using another syntax or another function called as a tuple. So tuple in case of Python is a function which is going to give you an empty tuple. So this is tuple2, and tuple2. That's it. This is the way you can do it. Now, this is the most important point. I want you to pay attention to this one. Before I write that condition, let me just call that function and make sure that you are getting it. All of them are the lists and tuple objects. Okay. Now, this is the special case for tuple, and because it's a special case, I'm going to put one line in between. So let me just go back here and say *30. So it's going to create a line, and now watch this closely. Last time I talked about list with only one value. I'm going to do the same thing with a tuple as well. Not list, but tuple with only one value. Now you may say, what's a big deal? Because what you can do here is just go back and replace it with 10, isn't it? It's very simple to do it. Watch what happens. This is one of the interview questions I generally ask the Python people to understand whether they know tuple or not. Now, I mean, as per comparing with that list syntax, it has to be a tuple with only one value 10. But you know what? It's a Python. Python is smart enough. See what Python thinks. Python thinks that ultimately when you are using a tuple with only one value, you will not be able to modify it because it's a tuple. Tuple means it's a read only. Read only means you cannot modify this collection. You cannot add anything into it at runtime because it's a tuple. It's a immutable object. Now, if it is immutable, what's the point of creating a collection? So behind the scene, when you say tuple 3, it is going to consider this not as a tuple, but as an integer. That's the one which I wanted to show you. So when you are using a tuple, and if you want to create a tuple with only one value, don't consider this as a tuple with one value. This instead is an integer value, not a tuple. Now, why it is an integer? Because 10 itself is an integer. Just for an example, let me just come back here and say this is another example of a tuple with only one value. So probably I'll say this is a 4, and instead of saying 10, I'll say something like India. So basically this is tuple 4, this is tuple 4. I know it's useless to have a tuple like this, but this is again, you never know, that's an interview question. So see this, it's not going to be considered as a tuple. Instead, it is going to consider it as a string. So this is a kind of an exception to the rule what we have seen earlier. So please remember, if you want to create a tuple with one value, it's little bit different. So what I'm going to do here is I'm going to go back here and I'll say this is the next example. Let's say this is 5, and now I want to create a tuple with one value. So if you want to create a tuple with only one value, which is again not very often that you need it, but again it's one of the interview questions if you are going for a Python interview. So you need to know you have to have a comma right after that value. Otherwise, it is going to consider it as an integer. Watch what happens here, and watch what happens here as well. So this is tuple 6. All I'm going to do here is I'm going to put a comma after that value. So now if I say run, probably you can see that it's now consider it as a tuple and consider this as a tuple as well. So please remember, when you are using a tuple with one value, it's mandatory for you to add a comma if you really want that to be considered as a tuple. Otherwise, you will see that it is going to consider it as a integer in this case, as a string in this case. And probably when you are in PyCharm, you always will get a kind of, the suggestion. If you just hover your mouse, after a couple of minutes, it will appear. Sometimes it appears fast, sometimes it appears maybe a little bit slowly. So it says, okay, not this one. Oh yeah, here it is saying remove the redundant parenthesis, because you know that if you are anyways using the parenthesis, it is going to convert it into integer. The same thing I think it is telling me here. So remove that redundant parenthesis, because by default it is going to consider this as a string, so that parenthesis is useless. That's what it is suggesting me. Anyways, forget the PyCharm, but remember this rule that you have to use a comma if you really want to consider this as a tuple with only one value. That's a kind of exception to the rule what we have seen earlier, but this is how it is. So remember this, okay? Who's that? Adesh. So which operation we can perform on tuple? Wait a second, I'm going to talk about it. Abhilash, then how it is possible tuple without any value? Exactly, I said that. It's pretty much useless to have a tuple like this. It is pretty much useless to have a tuple like this. But again, you know what? These are the points which, if you are going for an interview, then these are the points that you have to remember. Or if you are going for a kind of, Python exam somewhere, then you will see these kind of tricky questions. That's the reason I'm showing you all the possible options here. So Abhilash, I know in practical or in real life, these two tuples, empty tuple and tuple with one value, both of them are pretty much useless, but still you need to know them. That's the reason I'm showing you here. I hope you don't mind, Abhilash. Okay. Yeah. New tuple is equals to tuple 10. Will it be a tuple? No. Prashant, I don't know whether you are looking at my screen or not. This is the exact same example I talked about here. Tuple 3 is equals to tuple is equals to 10. It will not be considered as a tuple. Tuple, you're talking about the tuple here. Yeah, tuple will always consider this as a tuple. Give it a try and see that. Okay. Now, what is that, Jagrat, your question? Is this a language decision to include the functionality like a tuple instead of using the keyword like const, which will make like a const, or is it any big reason that the separate functionality of a tuple? Now, when you talk about Python, unfortunately, you cannot use a keyword called as a const, or keyword called as a var, or keyword called as a lit, like you can do it in other languages. So this is consider this as a constant. Consider this as a constant collection, not a constant single value. This is a constant collection. So this is the collection by, collection, when I say collection, it's like collection of multiple values. So by its own, it's a collection, but the only difference is this collection cannot be modified. And it's not only the language decision, but it also a kind of a feature that you always find in other languages as well. For example, if you're coming from Java, then Java's array is by default immutable. But if you want to create any mutable collection, then you should go for Java's collection framework. So java.util is where you can find the array list, then DQ, Q, and so on and so forth. There are 5 interfaces, almost like 24 classes out there, and all of them are again considered as a collection framework in Java. So probably when you want to go for, let's say, C++, there by default array is nothing but the immutable array. But if you want to go for mutable, then you have to go and play with the pointers. So every language has that feature. In Python, the feature is pretty much simplified, and simplified to the extent like they have created 2 different collections for that. One is a tuple, which is immutable, and the other one is kind of a list, which is kind of mutable. So you can modify that. Here, tuple cannot be modified. I hope, Jagrat, you got your answer. Who's that? Rohit, even if I define a value with no brackets, it's still considering this as a tuple. Yes, that's another story of it. Now, when you are that's what I said earlier, by default, you should always consider this, you should always consider a tuple. So probably this is another good example of it. So maybe I can say 7. I can say 10, 20, 30, 40, and 50, for example. And if I want to convert them into a tuple, I just put a round bracket after this. Okay, so this is a tuple. Now, when you know that, and this is what I just mentioned, like always prefer using tuple. So if I use that tuple or tuple 7, I know that it is going to be considered as a tuple, and you see that the class is equals to tuple. So now when you are using Python, Python also does exactly same thing. So Python says, see, we are giving you a kind of best practices saying always prefer immutable object. And if you want to do this, you don't even have to supply round bracket. You can simply say 10, 20, 30, 40, 50, and this is going to consider it as a tuple. And you see that this is by default getting wrapped using the parenthesis, and this is considered as a tuple. Excuse me. So till last, or till line number 51, we talked about empty, we talked about a tuple with 1 value. Now when you talk about a tuple with multiple values in it, you have 2 options. Either you can put the round bracket, or you can literally script round bracket, and by default this is going to consider as a tuple. I hope you can understand. Tuple is the way here in this case can be created by using a round bracket or without using a round bracket. So this is another way to create it. So that's a reason why you are getting that, you are getting this feature here, Rohit. Okay, so this is the answer to your question. By default, any language will tell you the best practice is always prefer immutable. Python does not even recommend it. Python does it. If you're not specifying any bracket there, by default, it will consider this as a tuple. Okay. There is one more thing. Actually, I'm going to talk about the similar syntax, not right now. I'll talk about that later in a sense, once we are done with this. Okay. Just remind me that I need to talk about one of the features of tuple right after this. Okay. Just wait for a minute. I'll talk about it. Let's first finish the answer to your questions. Someone was asking that question, like if it is the case, then which other functions or which other methods are available? Very simple. All these methods related to the immutability are missing. In a sense, if you are creating a tuple, let me call this as a tuple, and instead of saying tuple, let me just call it as a numbers. Simple to understand, simple to modify, simple to play with. So this is a tuple. You may use round bracket or you may not use it. Just for readability, I'm using parenthesis. And again, please remember, this is optional. I mean, you may use parenthesis or not. By default, this will be considered as a tuple. Anyways, so now we have a tuple with us. I'm going to play with that tuple and see what are the different functionalities available. Again, maybe this is a immutable tuple, immutable collection. So you will not have something like the append, something like remove, something like pop, something like maybe all these which are required to have a collection which is immutable. So what functions are available? The first function available is count. Count, you know, you already have played with this, you already have seen that earlier. So probably I'm going to come back here and say 50, let's say 60, 80, 10, 20, for example. So if I want to find out how many times value 50 is repeated, same story, what we have seen earlier. I'm not going to waste more time into it because we already have talked about this at length yesterday. So this is how we are going to get the number of times 50 repeated. Okay, this is the count of 50. That's it. So probably I'm just going to go back here and say this is count or 50 appeared. 50 appeared, no, not appeared. Okay, 50 appeared maybe these many times. How many times? I don't know. I'll just go back here and say count 50 times. That's it. This is the way you can do it. That's the first function. And second function, because it is appearing multiple times, I want to get the index position of 50, for example. Again, this is the position 50, which is equals to numbers dot index and 50. That's it. Other than that, there is no other feature, there is no other method available on tuple. So that's how you can do it. Now 50 appeared at this position. So this is position 50. That's it. So this is how you can play with that tuple, and these are the only methods available on tuple: index and count. That's it. So these two are having exact same meaning as that of the list. There is no other method available here. Okay, so these methods are kind of missing, like append, pop, insert, so on and so forth. All of them are missing. You cannot deal with them. I hope you are getting it. Okay. Maybe another quick question. Where is it? Where is it? Yeah. Okay, Digvijay, your question. Tuple 3 and tuple 4 are modifiable. Tuple 3 and tuple 4. Tuple 3 and tuple 4. What is that? Tuple 3 and tuple 4. Tuple 3 and tuple 4 are not tuple at all. Probably, Digvijay, you missed the point which I said earlier. This is tuple with one value. Though I said it is a tuple, but I don't know whether you have seen this or not. This is rather an integer, not a tuple. So tuple 3, let me put it like this way. Tuple 3 is an integer, while tuple 4, I mean, though the name here is tuple, but still tuple 4 is a string. Now tell me one thing, if it is an integer or if it is a string, can you not modify it? You can, isn't it? So you can, and that's the reason why they are modified. It's not like tuple is modifiable. It's because both of them are not tuples. Both of them are pretty much integer and string, the default types. And that's the reason why they are modifiable. Okay. Good observation, Digvijay. But this has been, I mean, it's been already assumed that this is not a tuple. By default, they are kind of modifiable. Okay. So hopefully that answers your question. Aisha, proper reason for this exception. Which exception you're talking about, Aisha? I'm not sure which one you're talking about. I'm not in the context right now, so tell me which exception you're talking about, and I may answer that question again. Vivek, by the time, let me see the next question. If tuple is immutable and we cannot do any operation under, what's the use of tuple? Very good. What's the use of tuple? You are asking a question to the Python like, are you crazy? If you cannot do anything with the tuple, why the hell have you provided that feature, isn't it? Now let me tell you this, why the feature is provided. Now imagine that you are writing an application and say you want to display the list of countries. Let's say you are designing a form, just for an example. You are designing a form, maybe a GUI form, where you want to provide an option for user, a drop down where you want to see the list of countries. Now you know that your application is available in only few selected countries, and you want to give only restricted list of countries, which means I know which countries a user is going to select beforehand, and that's the reason this collection I don't want to modify it. So if I know that my collection is not modifiable, what's the point of it by creating it as a list? So if I know I'm going to support only these countries like, let's say India, for example, again, let's say, China is banned. So India, USA, and UK, that's it. So these are the countries I know I'm going to play with. What's the point of creating a list out of it? That's a reason why tuple is provided. So that's a main reason why tuple is provided. I hope that answered 50% of your question. So in this case, I know countries is not going to get modified, and that's the reason why, if you ask me, I would prefer using a tuple than a list. And it's not only me, it's a standard practice that always prefer immutable over mutable. So that's one reason. Now, another quick reason, maybe I can talk about here. Maybe I can just drop that function, and let's go for another function, like what should I say? Let's say math operation. It's not math operation, it's like math operations. Now, what am I looking at here is a function. Pay attention. So all of you will get another reason why tuple exists. This is the feature I wanted to talk about. I said I'll talk about one more feature of tuple. This is the feature here. So probably that answers your question as well. So I want to perform a math operation here. So I'm going to pass P1 and P2, these two parameters, and I want to get, let's say, addition multiplication, subtraction, and division, all of the 4 operations there. How do I do that? Now, probably I can easily do it by saying addition equals to P1 plus P2. Now, till this time, you could have returned this addition, and you know what? You could have gotten that result here, and you would have gotten the addition of it. Let's say 10 and 20, for example, or let's say 40 and 20, for example. So, till now, whatever we were doing with that, you could return only one value. But now, actually, I don't want to return only one value. I want to return 4 values because to be precise, I don't want to stop here. I want to go for subtraction as well by saying P1 minus P2 like this. I want to go for the division by saying P1 slash P2. And I also want to go for multiplication and multiplication. And that I can easily do it by P1 multiplying P1 and P2. So probably this is what I'm going to do, or rather I'm hoping for. So how do I do that? Unfortunately, it's not possible for me to return multiple values in other languages, not in Python. In Python, you know what? I can just club them together and say addition, subtraction, division, and multiplication. That's it. Oh, what do you mean by that? Are you returning multiple values there? Of course not. I'm still returning only one value. But have you seen the feature which I talked about earlier? Is you remember this particular scenario, line number 60? Line number 60 is where I showed an example where even if you do not specify any parenthesis, by default, it is going to consider it as a tuple. So basically what it is doing behind the scene is like this entire values collection, like addition, subtraction, division, and multiplication, this entire values collection, they are kind of wrapped by using parenthesis, which is not required in this case. And those values can be retrieved by using result. So probably if I just go back and say, hey, give me the result. So probably if I look at the result is again a parenthesis, means it's a tuple. And you see, this is 60, 20, 2.0, and 800. Probably this is exactly what I can achieve with something like a tuple, which is not possible in any other languages. So there are very few languages where this feature is available, where the feature is kind of visible. Another language which I love other than Python is Swift. Swift is again inspired by Python. Many of the features of Swift are inspired from Python. This is another example where you can, or this is the example which you can be, you can also implement in Swift as well. So this is a use case where the tuple is the best collection you should go for. I still can do it by, you know, modifying that collection or adding all of them into a something like list. I can still do it, but don't you see that if I do it, then anyone can modify it. So anyone can say, before modifying the result, anyone can say, hey, result dot append 100 or maybe 1000, and it is going to change the entire meaning to your result. So basically, whenever you're returning something, I don't want anyone to modify my return value. And if you want to do it, then always prefer using tuple. You see, this is another case. If I really want to get the addition, subtraction, and all of them here, probably I can say this is going to be an addition. I know addition is there on the 0th position. Again, this is a collection. Whatever we have said, let's say answers better. So whatever we are using here, that answers is a tuple, and tuple and list, both of them will be accessed by using the same logic, same syntax. So this is a 0th answer, that is an addition. This is a subtraction. This is a division, and this one here is multiplication. So naturally it's 1, 2, and 3. So that's it. 1, 2, and 3. So when I say run, probably you can see that addition is 60, subtraction is 20, division is 2.0, and multiplication is 800. Exactly what I was hoping for. So this is another use case where Python is required, or Python is used. Okay, so who asked that question? I don't remember, but this is the answer to your question. You know, oh yeah, Vivek, you asked that question. If the tuple is immutable, then what's the use case here? Then probably you might understand that this is where Python is going to give you a tuple, which is a very simple way to perform operation where you can return multiple values together. Okay, now I hope you appreciate Python's thinking process. That's Python in the sense, Guido Rossum's thinking process. He's the person behind that language, you know. It's a great person. So he already has thought of many different scenarios, and then finally he has implemented that feature. So Probably this is a kind of this is the kind of a feature which only few languages will provide. Python is one of them. Rather, Python is first one of them. I mean, there are few languages which got inspired, but Python was the first one of the first languages where this feature was available. Anyway, so this is the way you can do it. I hope you know, or now you appreciate that another tuple. I hope you know where you can use that tuple and where you can prefer using a list. Simple rule: if you want to modify the collection, go for list. If you don't want to modify the collection after its creation, always prefer using tuple. And rather, I would suggest always prefer tuple irrespective of condition. Only when you want to modify it, then go for list. Otherwise, always use tuple. There is another advantage of using tuple here. So when you are using tuple, the accessing becomes exactly same. I'm not going to show you any of the examples again because we already have talked at length about what do you mean by indexing and what do you mean by slicing. Both these features, indexing as well as slicing, both these features are applied on tuple as well. So basically, if you are saying, no, list provides this feature, so it's better we should go for list. It's not required because list and tuple, both of them will provide exactly same features. So you can create a tuple and you can perform all these operations we have talked about in the indexing case, and you can talk about or you can use a tuple and perform all the features, all the examples which we already have seen in the slicing part. So slicing and indexing, both of them are applied on a tuple as well. So that's what I said. Always use tuple. Only in case you want to modify the collection, just go for list. Otherwise, it's better to use tuple. It's better to use immutable object than using mutable objects. So that is how we can do it. Okay. Okay. So I hope you see how simple is that to deal with the collections like tuple and list. Guys, can you please give me the confirmation whether you have understood this or not? I hope yes. I think I can get a couple of yes there. That's good. Okay. Aisha, I think, yeah, I forgot to answer your question. Tuple 3 equals to 10. Why is this integer? Why not tuple as a syntax is same? Aisha, this is the language fundamentals. I mean, if I just ask you a quick question, if you already have coming from C or C++ or Java, in other languages, you say integer num equals to 10. Have you ever seen in C saying var num colon integer equals to 10? Have you ever seen this one? I don't think, because this is not a syntax of C. This is the syntax of Swift, by the way. So when you are in Swift, you are going to follow the Swift syntax. When you are in C, you are going to follow the C syntax. Same thing. When you are in Python, we are going to follow the Python syntax. So this is just a syntax. So example, tuple 3 and tuple 4, both of them, you can think of them as exceptions, or you can think of them as different syntax in this case. Okay. So exceptions to the rule of tuple. Though we are using parentheses, still they are going to get converted to the simple variable, simple types. And there's a reason behind this. I already have mentioned the reason. Ultimately, when you are using this tuple with only one value, you will not be able to modify it. And if you're not able to modify it, by default, Python says, why should I waste my memory by creating a separate tuple for it? So for this tuple 3 and tuple 4, it is going to downgrade it from collection to a simple type. That's how it does it. Okay. Okay. Rajendra, how to create a constant? Yes, I'm going to talk about this, but for that we need a separate package. So hold your question. I'll answer that question later once we look at the module and the package. Okay. Okay, so now hopefully you know what exactly do you mean by tuple and list. You know the difference between them. Now we want to go for the next example, the next type of collection. The next type of collection, oh, by the way, this is a kind of a quick comparison. Don't look at this from this point. If I just convert that to the PDF will look way better. So this is where you are going to get the PDF table where you can see the list versus tuple, what exactly the difference between them. This is mutable, this is immutable, uses square bracket, it uses parentheses, and the list with one value is this, and list with one value, the tuple with one value requires or mandates you to use comma. If you forget to use comma, nothing is going to work. So this will by default get converted into simple data type there. Okay, that's how it does the job. Okay, so now you know tuple, now you know list. Let us continue further and see what do you mean by a set. Now, probably if you can recall, once upon a time when you were in school, I hope you might have heard about a set theory. So a set theory is exactly what we are going to see now. So what is a set? Probably if you can recall, a set is nothing but collection of unique values. Now, till now, both the collections we have used, they both allow duplicate values. Now, if you don't want to create a collection with the duplicate values, you should prefer using a set. I'll show you a couple of examples, see whether you can get this. So this is a page 4, for example, here. And I'm going to start with function 1. Again, please pay attention. This is numbers 1 collection, which is a list, by the way. And I'm going to put some values 10, 20, 30, 10, 20, 30, again 10, 20, 30. So I'm just going to put some values which are duplicates. This is a list, by the way. This is a kind of a tuple. I'm just going to copy this one here and say this one more time. This is a tuple. And because it's a tuple, I may or may not use a parenthesis. Both of them are perfectly all right in Python. So probably I'm going to talk about this and say this is a tuple. I'm sorry, this is a numbers 1. I know it's a list, but it's better if I just prove the fact that this is a list. At this point, we don't have to because we already have gone through these examples a couple of times, but you know, it's always better to do it. And that's a reason why I'm kind of duplicating the same code again and again. It's okay, doesn't matter. And the next one I'm going to try here is something called as a set. Now, please remember, when you are going for a set, the set will require you to use something like a curly bracket. So curly bracket is used for both set as well as dictionary. Once we are done with set, we are going to talk about something called as a dictionary. And dictionary is also going to use the, it's going to use the the curly brackets there. But there is a difference. We'll talk about a difference right after we are done with set. Let's focus on set first. Now, please pay attention to the output because output will tell you what's the difference between list, tuple, and a set. When I say run, you probably will notice that the first collection is 10, 20, 30, 10, 20, 30, 10, 20, 30. This is a list collection. The second one is going to have the same values, but the data type is kind of a tuple. But the next one, if you look at this one, it is not having 10, 23 multiple times. Here you are having 1 time, 2 times, 3 times, but here it is having only 1 time. The reason behind this is very simple because it is of type set. So what is a set then? A set is the collection of unique values. So it will never allow you to have a duplicate values there. Now, when I say it is not going to have a duplicate values, that simply means even if I'm having, let's say 10, 23 repeated multiple times, by default, set is going to consider them only once. And that's the reason if I print that set here, you see, I'm getting only 10, 23 and not the repeated values of 10, 23. That's the reason why set can be used. So probably if someone is asking you like, hey, I have got these values, maybe 10 to 30, for example, like this. And if someone is asking, hey, just tell me how many values, how many unique values I have in my collection. Just convert that to a set and you are done. How do you convert that to a set? I'll show an example here. Probably you can say this is a tuple or this is a list. Doesn't matter. Maybe I'll say this is another example of a list. For example, again, doesn't matter whether it's a list or tuple. Concept is going to be remain same. So I'm having some values here. Let's say completely random values. Say this is 10, 20, let's say 49, 20, let's say 40, 58, 60, and so on and so forth. So if someone is asking, hey, tell me what are the unique values available in that list? Very simple. I'm going to convert this into a set. I'll say set 4, which is equals to call a function called as a set and pass that numbers 4. And that's it. You're going to get the unique values there. So probably I'll say unique values. Or you can simply print that set 4 because set 4 is going to have only unique values. And if I say run, you see, this is the unique value. Okay, I forgot to print the original collection. So probably I'll say this is the numbers 4. So you will compare both of them and we'll see the duplicate values are skipped. So if you look at this one, seems like there are only 2 values which are duplicated. I hope maybe this is the 20 and 20. The rest of them are already unique. So you see that these are the unique values. 20 is getting repeated twice, but it is considered only once here. Here it is. So it has considered that 21 times and that's, or maybe, yeah, 21 times. And that is how it is going to find out all the duplicate values. I think 10 is also considered only 1 time because 10 is also duplicated. It is going to get considered only 1. And you see, this is a kind of use case where set is used. What's your question, Preeti? The places of the values are random or changed within the printing set. Exactly. when you talk about the set will never allow, so it will have its own insertion order. So here, this very second statement, it talks about what you are asking, Preeti. So here, it does not follow the insertion order. When you say it does not follow the insertion order, see, the insertion order for number 4 is like 10, 28, 72, blah, 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 blah. So I see that the list is following my insertion order. List is following all the numbers in a particular sequence if I'm adding them in this one. So probably in case of set, it's not respecting my insertion order. So if I use this order 10, 28, 72, blah, 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 set behind the scene is changing its order and is giving me all the unique values. So Preeti, to answer your question quickly, no, it will not follow your insertion order, but it is going to follow its own internally. So we cannot control that. Unfortunately, when you talk about the set will have its own insertion order and it will never respect your insertion order there. Okay. Okay, next one. Who's that, Vipin? It is always considered the first occurrence. You can say so. It's going to always consider the first occurrence, or you can say, even though it is appearing multiple times, still it is going to consider those values only one time. So that's what it is doing behind the scene. Okay. The next one, Dipanjan, what does the set following? Okay, so you got that answer. Very good. So now you know how set looks like and what exactly the sets requirement. So the sets requirement here is like it should consider only the unique values. Chandrakant, can we modify set ascending or descending? Wait. We are going to come back to the operations we can perform on the set in a minute. But before that, let me tell you what exactly the requirement of set from a different perspective. Do I have that? Okay, I don't have it. I hope so. Just give me a sec. I'm sorry, not here. I will have to see whether I am having it here or not. I'm not having it. Not a big deal. I'm going to create a different directory called as Python. And what I'm going to do here is I'm going to put this one here. Better do it, please. And this is not required. I'm going to delete that anyways. We'll create this file one more time, PDF file one more time, and I'm going to share that with you. So hopefully you will see the new version of notes today. But before that, let me tell you what exactly the set theory means. This is what about the set theory is. So pay attention and see where and how set can be used. Now you might have seen this particular diagram. So say that there are two sets with us. Let's say this is my set 1 and let's say there is a set 2. So probably there are two sets. This is how we are going to play with them. So probably I'll say that these are the sets and I want to play with them. So let's see what do you mean by that. So probably the set 1 is going to have some values. Let's say 10, 20, 30 and 40. For example, again, important thing is the concept. So values may change over the period, but concept is same. The concept is important. 40, 50, 60 and 70. So that is how we have created two sets. Imagine that there is a set 1 and set 2. I'm going to call this one as a set 1. Say this is S1. And I'm going to call this as a S2 or set 2. So probably when I say I have the values like, or I have the sets like 1 and 2 or set 1 and set 2, I want to perform some operations with these sets. So what are the different operations you can perform? I bet you might have heard about them before. So when you talk about a set, multiple sets can be intersected, or you can get the union of union of set, and you can get the subtraction of set, and so on and so forth. So you might have seen these examples earlier. This is exactly what I'm going to talk about here. So pay attention and see what exactly you can do with it. So this is my set 1. Probably I'll just keep that right now. Should I? Okay, let's do it here. So let's say I want to have the first operation. That's something called as a union. So what is a union? Union means adding both the sets together. So that's what you mean by a union example, you know. So I can put that right here. So maybe I can just go back here. What the hell? Okay, let's try the other one. Finally. Okay, so this is the one, and I see like there is an area which is common between these two sets, you know. So we are having 10, 20, 30, 40, then 40, 50, 60, 70, which means both of them are having one element common. That's 40. So what is going to happen here? You see, the common elements will be kept only once and uncommon elements will be added together. So it's like 10, 20, 30. 40 is common in both of them. So 40 will be appearing only once because we are talking about something called as a set. And again, 50, 60, 70, and 80. So this is how we are going to get the, I'm sorry, 80 is not required. So it is nothing, it is not there. So this is how we are going to do in case of union. So this is called as a union. I bet you might have heard about this symbol as well. So it is called as a S1 union S2. So this is S1, this is S2, and this is how you can perform that operation. By the way, if you go in the reverse direction, so probably if I say that S2 union S1, probably you know that it is going to give you exactly same result. So you go by this way or you go by this way, ultimately, you know, you are going to get the same result. S2 union S1 is equals to S1 union S2. I hope you are getting the point. It's very simple and it's very straightforward. So probably you might have heard about this before. You might have seen that in your set theory in school days. So this is exactly what we are going to do now. Okay, let me show you an example of it. So come back here. I say this is S1, which is having, I'm sorry, this is a set. You know, set can be created with the curly brackets. So now I'm going to say it's 10, 20, 30, 40 using the same values there. And S2 is equals to 40, 50, 60, and 70, for example. So now if I go for, let's say, print, I'm directly going to print the result. You may want to get a separate set out of it. It's up to you. So I'm going to say S1 union S2, which is equals to S1 union S2. That's a method we are talking about. The same thing, I want to print it one more time by saying S2 union S1, just to prove the fact that though you are going for S1 union S2 or S2 union S1, both of them will give you exact same result. So this is function 2. When I say run, you see both of them are giving you exact same result. Important thing is just pay attention to value 40. Because the value 40 is here and here, still it is not appearing twice. It's just appearing only once. That means this is exactly what you are going to get there. So probably what I'm going to do here is like, I'm just going to put the area which will be considered here. So this is a kind of union. You're just adding all of them together, keeping the common elements only once, and this is how you are going to get the result for a union example. So this is a union between S1 and S2. Okay, very simple. So hopefully I already have mentioned that in your so-called notes right here. This is the intersection, this is union. So what I'm going to do here is I'm just going to make your life a little bit simpler just by just adding this particular diagram into your so-called notes. And anyways, I'm going to provide this to you in a moment once we are done with this. What the hell? Just give me a sec. Copy, do it again. I'm going to save that inside my directory, so-called notes. Should have done that earlier, but it's okay. Nevertheless, I can do it now. I'll say this is a set underscore union. Why am I doing it? I'll show you that in a second. Let me come back to your so-called notes. Let me, union, where are you? Here it is. So union is here. I want to put that diagram right here. So I'll say, do I remember the diagram? Sorry. Okay, so seems like this is the union diagram for union. Oh, what is that? Set union, I guess. Set underscore union dot PNG or JPG. I think it's a JP. Oh yeah, it's a PNG. Exactly. So now your PDF is going to have this diagram, so it will be easy for you to see what exactly the operation looks like. So this one will tell you like what exactly the union is. I'm having different values. 10, 20, 30, 40, and 30, 40, 50, 60. I should have paid attention to these notes. So, okay, for this, just consider the case, okay? Otherwise, I'll have to change the entire diagram again. It's okay. Probably 10, 10, 20, 30, 40, and 30, 40, 50, 60. It's better I can just change the second one for at least a couple of next examples. It's better to do that quickly. Nevertheless, it's better to have the notes ready and probably you can use them later. So maybe I can do this quickly and say, yeah, modify this a little bit. Yeah. So this is how we are going to do it. It's like 30, 40, 50, 30, 40, 50, and 60. Sorry, 30, 40, 50, and 60. Only only change here is you are going to have the 30 and 40 in common. That's it, because you are going to have 30 and 40 in common. So 30 and 40 will be there inside this common area. Naturally, this is also going to change a little bit. This is not required here. I changed the entire diagram, you know. It's okay. I can just remove it and quickly write it here to just save your and my time. This is something which I believe, and it's not like me. In fact, this was said by Newton once a time. Newton said that if you want to remember something for a longer time, always create a diagram out of it. You'll be able to remember it throughout your lifetime. This is same story what government must have already heard about, and that's the reason they have taken the decision to change the statutory warning on a cigarette wallet. You must have seen that. Nowadays, it's also showing the warning cigarette smoking is injurious to health. At the same time, they already have shown a photograph of a person having a cancer in it. You know, so they already have done that experiment, I guess. People didn't read those messages there, so that's the reason they have taken the same decision. So they must have heard what Newton said earlier. It's a good thing, actually. So that's what I'm also following here. So basically, when you talk about something like a diagram, you can remember it more time, or remember it for more time, for longer time than a text reason or textual information. That's the reason why I generally convert everything in a diagram. And this is a pretty simple one. So let me just quickly modify this one, set union. Yep, override it and just confirm that whether it is modifying your diagram or not. Are you kidding me? Just give me a sec. Let me do it one more time. Okay. Well, finally, it got modified. Very good. So this is a union. Union means you're just going to keep the common element only once. That's it. Okay, so you know that this is the union now, and probably I can change my example as well just to match with the diagram. So this is 30, 40, 50, 60. That's it. No efforts are required here. Just run the application and you will see exact same result. So 30 and 40 are appearing only once. That's the main thing we should look at. Okay, now the next example is about the reverse operation. That's the intersection. So when you go for intersection, again, I can just go back here. Should have created that earlier, but it's okay again. It's good thing that we are looking at it at runtime. So probably it will be easy for you to see how does it work. So this is how we are going to do this. And probably this is going to give a chance to see what that operation result will be. So that's it. We don't need this either. So I'm going to delete that as well. And probably I'll just create a copy of it so that I can reuse it for the next operation. Do it later. Okay. So let's do it quickly now. So we are having 10, 20, 30, 40. 30, 40 is common. Again, it's 10, 20. Oh, sorry, forgot that. We'll have to use the white color again because now we'll have to look at the intersection. And I hope intersection is nothing but the common area. The common area is this and this. So probably when you're talking about a common area, that's what you are going to select. So that's 10, 20 is on this side. The uncommon elements 50 and 60, both of them are on the other side. On the other side, here we are having 10 and 20 again on this side. So probably this is how we are going to do it. And 30, 40, both of them are common elements. So I can say 30 and 40, they are common. So the operation we are performing here is called as intersection. And intersection is finding out the unique, the common elements or the common values between two sets. So this operation is called as S1 intersection S2. Unfortunately, I can't just go for that, I mean the U there. So what I'm going to do here is this, called as S2, S1. So probably this is how I'm going to do it. Both of them will be exactly similar. S1 union S2 and S2 union S1. Both of them are exactly similar. So probably what I'm going to do here is this. Quickly, just modify that a little bit. And I'll say that this is the intersection. I'm sorry, this is the intersection operation. My bad. Okay, so this is the intersection, and this is the intersection between S1 and S2. And this is an example of intersection of S2 union S1. I'm sorry, S2 intersection S1. So probably you will notice here, both of them will give you exact same result, because this is again a same, you can say it's a common elements between S1 and S2 or S2 or S1. So both of them are exactly similar. So this is the intersection. So let me copy this. Sorry, not this one. Let me copy this one. Sorry, my bad. Let me copy this one. Save that diagram and refer it in our so-called notes. I'm going to share that notes later with you, so don't worry about that. This is again set intersection. And let me come back to your so-called notes. Copy this here, and this is where you are going to get the intersection. So this is not union, this is an intersection. Okay, so this is intersection, this is union. So you will see what exactly meaning of intersection and union. And if I want to do it in Python, it's pretty much simple. All we are going to do here is this. Simply copy, paste. I'll say S1 intersection. Why am I writing it again? Just give me a sec, guys. Here and here, I'm going to do it with only one single V. I'm just going to show that this is intersection. That's it. So this is going to give me a result of intersection, and you see that S1 intersection S2 is 4030, and S2 and S2 intersection S1 is again 4030, which means we are going to get only the common elements between them. That's it. So that is how we are going to play with the set. And there are two operations we have seen so far. Both of them are exactly similar for S1 and S2, or S2 and S1. So that is how you can get it. It's called as intersection. The other one is called as union. There is one more property, there is one more method, which is called as a difference. Sometimes it is called as a subtraction as well. So let us see how different it is when you are going for S1 minus S2 and S2 minus S1. And to understand that, it's better we can just come back here. And is it possible for me to do it quickly? Yeah, it is. I'm just going to change this one, this again is white, this is again in white. Okay, so what I'm trying to show you here is another operation. This operation is called as S1 minus S2, or S1 difference S2. This is S1 minus S2, and this is kind of S2 minus S1. Now, probably this is pretty much common in mathematics, that A plus B is equals to B plus A, but A minus B is not equals to B minus A. So that is the reason why I'm trying to show you these two, for all the operations there. So what is S1 minus S2? S1 minus S2 is selecting that portion, or selecting those elements which are uncommon between S1 and S2. So because you are talking about S1 minus S2, you are going to select only those elements from S1 which are not common with S2. And when you say S2 minus S1, you are going to consider all those uncommon elements from S2 which are not there in S1. So this is how you are going to get the result for subtraction or for difference. I hope this is simple to understand. This is a kind of a set which is going to give you an operation called as a subtraction or difference. It's also called as a difference, or it's also called as a subtraction. Difference. Okay, so let me come back here. First, let me put that diagram here, and I'll say this is going to be the, this is going to be the exclamation mark. This is difference. And I'll say that this is, or maybe, okay, fine. This is set underscore difference dot png. Yes, here it is. So this is the set difference, and you see that the set difference is not exactly similar. It's not cumulative. So it's not, it's not cumulative, it's not symmetric. This property is called as symmetric. Symmetric in a sense, S1 minus S2 is not equals to S2 minus S1. This is symmetric. S1 union S2 is S2 union S1. This is symmetric. S1 intersection S2 is equals to S2 union S1. S2 intersection S1. But a difference is not symmetric. So probably I'm going to copy this again like last time. And I'm going to say that this is the difference now. Sorry, this is the difference. What the hell? This is the difference. You may say difference, or you may say minus as well. Huh? So both of them are perfectly all right. You can go for, you can go for difference, or you can also go for minus. Both of them are absolutely right. So if I just go back here and say run, you see that S1 minus S2, S1 minus S2 is giving you 10 and 20, and S2 minus S1 is giving you 50 and 60. And this is exactly matching with our diagram. S2 minus S1 is 50 and 60, and S1 minus S2 is 10 and 20. So this is how you can play with set, and you can get those methods there. There are a bunch of other methods, but right now the important thing is how to play with those important methods like union, intersection, and difference. Rest is the story what we have seen earlier in set, earlier in list. So probably set is also a mutable object. Now when I say mutable, that simply means I'm going to go back here. I'll say this is function 3. Watch what I'm trying to show you here. This is S1, which is the set, let's say 10, 20, 30, 40, and 50. It can be unique at the time of adding the values, or even if you are duplicating the values, still S1 is going to consider only unique values. First, let me print the values, like print S1 and say this is function 3. Watch what happens. So this is again not following my insertion order. It's not respecting my insertion order because it has to just check whether the values are unique or not. So it uses hashing behind the scene, and it changes the values, or it changes the order of that insertion. And I don't care about the insertion order, because if I do care about the insertion order, then we'll have to go for the list or tuple. Here, when you are going for unique values, you cannot get the insertion order. So this is again, you have to decide whether you want to really need this or not. Anyways, so coming back here, I'm going to add a few values inside my S1. So here, the operation I'm going to perform is appending a new value. But here it's not called as an append. Here it's called as adding a new value. So adding a value. Add operation, for example. I can say S1 dot add, and in this case, I can add value 60 and 70 and 80, for example. I'm sorry, we want to add only one at a time. So S1 dot add, let's say 70, and S1 dot add 80. So this is how we want to add the values. And if I just go back and try to put that S1, you will see that earlier we were having 10 to 50, but now we are having 10 to 80 values. Guess what? If I add that value 60 couple of times, 70 couple of times, 80 couple of times, again, it is not the case like all the values will be replicated, because we are talking about the set. Set is always going to consider only unique values. So even if you are adding this value multiple times, you see I'm adding 70, 60, 80 multiple times, still set has considered them only once, because the fundamental says, or the Python says, set fundamentally is a collection of unique values. So that is the difference between these two. So when you talk about the add is going to add anywhere. I mean, there's no insertion order here. So you cannot say that it is going to add towards the end of it, or it's going to add in between. I can't say anything about it, because for set, you cannot maintain the insertion order. I hope with respect to that list, we talked about how to get a value added towards the end of it, and how to get added that value in between by using a function like append and by using a function like insert. We can achieve both of them. But in case of set, there's only one option, and that is add. So if you are using that add method, and if you're adding something to the set, by default it will get added anywhere. So you can't guarantee that, and you cannot control that. So this is how it works behind the scene. Okay, so that's one of the methods with which you can modify the set. Now another method, anyways, I've added few values there. So time has come to remove the existing values. So for example, if I'm having one more function here, let's say function 4, and if I want to remove a value, let's say I want to remove value like 30. How do I do that? This can be done by saying S1 dot remove, the value is 30, for example, and probably I'm going to come back here and say this is print after I remove the value. So if I say function 4, you see earlier I was having value 40. Now the value 30 is kind of removed. See, 30 value is missing. There are two ways you can do it. Either you can say remove by using remove. So I can say remove a value. Naturally, because we are not following the insertion order, there is no way I can delete a value by its index. So index can be considered only when you're talking about a list, not even a case of something like a tuple, because from tuple you cannot remove anything. Tuple is immutable. Set is mutable, but you cannot remove a value by using its index. You have to remove the value by using the value itself. Okay, so let us see. This is an example of removing a value 30. There is one more way you can do the same thing. I'll say remove the value. And you can still say that by using something called as a discard. So there are two ways you can do it. One is a discard and the other one is a remove. So here I'm going to discard the value 50. Print S1. So when I say when I say discard, it is also going to discard the value is equals to 50. So in this case, we are removing value 30, and here we are removing value 50. Both of them are doing exactly the same job. Now you might be wondering, like, why on earth they have provided two methods for doing the same thing. I'll show an example, see if you can understand that. Now I'm going to discard, should I? Okay. So I'm going to remove a value here. Let's say remove 100. I know 100 is not there in the set, but I'm going to try removing a value 100 which isn't there in the set. Okay, so let me say run, and you see that your application is crashing. You might guess the reason, because when you talk about removing 100, the 100 must be present in that set. Because 100 is missing, probably maybe remove is telling me that you can't remove 100 because 100 does not exist in the set. So when you say remove, remove will raise an exception. This is the important point that you should remember. Raise an exception when a value is missing. So if you're trying to remove a value which is missing, the remove method is going to raise an exception. Let me try doing the same thing with discard. So when I say discard and say 100, and if I say print S1, let me just run this application, and you see that it is not raising any exception. It is just simply saying if 100 exists, I'm going to remove it. But if 100 does not exist, I can't do anything. It just simply discards the situation or discards that operation. So this will not, rather I'll make it precise, discard will not raise any exception if the value is missing. That is the only difference between a remove and the discard. I hope you can understand what do you mean by raising an exception now. Probably you see the application is crashing if you're not handling the exception. So probably the scenario here is, if you're not sure if the value present or not, you can go for discard. And if you're damn sure value exists in a set, then you should go for a remove. That is how you can decide whether should you go for a discard or whether should you go for a remove. So if you know the value exists, go for remove, and if the value does not exist, go for discard. Okay, so that's how you can take the decision. Both of them are doing the same job. One raises an exception if the value doesn't exist. The other one does not raise an exception. It just simply discards it if it is available. That is what you mean by using a discard and a remove. Vivek, if we cannot remove an element by using its index, then how can we iterate a set in Python? Iterate will be done by using the same way. For in loop. There is no index position, there is a for in loop. There is no way you can get the values like 0, 1, 2, 3, 4. That's not the way you should go for. You should go for the values like in a for loop. So that can be done by using the same technique what we have seen earlier. But here, when you're talking about the set, index comes secondary. What comes first is something like a unique values collection. That's the difference between a list, tuple, and a set. So Vivek, I think the requirement is a little bit different. So you're trying to compare it with list and tuple because we already have used the index positions there. So that's what you're saying, the index positions are missing. Yes, index positions are missing, or you can't go by index. But what you can achieve here, you can't achieve that by default in list and tuple. What is the achievement of set over the list and tuple is it's a collection of unique values. So that is what the achievement here is. Okay. Anyway, so when you talk about something like a set, you know that now the set is nothing but collection of unique values. There are different operations that you must have already seen in your school days: intersection, subtraction, and union. I think now your notes is also going to have the diagrams as well. And precisely, I already have shown in a couple of examples. And then if you want to play with it, you can also go for adding a new element or maybe deleting an existing element by using add, remove, and discard features. Okay, so that's how the set is implemented in Python. Okay. Pranav, your question, why they did not show the value in arranged manner? You'll have to call Guido Rossum to answer this question. It's like what they are doing behind the scene is like a hashing. So ultimately they have to see whether the values are unique or not. And to achieve that, they internally are kind of using the hashing function. So because of the hashing, the values are not arranged in an insertion order. So that's how you can get it, Pranav. Okay. Priti, is there any search function? Is there any search? Is there then search function? I'm not getting what exactly you're trying to ask. Are you trying to ask like whether we can search inside the set? Of course, yes, we can, but not like the search method is available. We'll have to do it by using a different technique. Okay. Most of the times you are going to use a set for just finding the unique elements of it. So once you find the unique elements, you can come back and convert that into a list or something like a tuple. And again, you can run a for loop for it. Okay. The searching is a little bit different in a set. I'll show a couple of examples later, maybe tomorrow, where we are going to compare a mutable set with immutable set as well. Probably we already have seen a list and tuple. A list is a mutable object and tuple is an immutable object. Similarly, the object we just talked about, which is called as a set, is a mutable object because it allowed me to add new values at runtime. And there is something called as a frozen set, which we are going to see an example of tomorrow, which is a kind of immutable set. And tomorrow we have to also see something called as a dictionary. And tomorrow we have to also see something called as a map. Where are you? A map and filter. I don't know whether it is here or somewhere here, but yeah, we'll talk about something called as a map and filter and a reduce. Not reduce, but map and filter at least. Okay. Someone was asking that question about how to get the lower case of all the values, or how to get the square of all the values. So tomorrow you will see that answer to that question. Okay. Anyways, I think we have seen one more collection today. That's it. We are going to finish that another collection tomorrow. The two collections tomorrow. One is the frozen set and the dictionary, and we'll play with some other things tomorrow. Okay. So I think it's better we can call it a day. Probably yesterday I didn't pass the assignment. Today I have the assignment ready. I was waiting for this topic to get finished. So now you are going to get a new assignment today, maybe in an hour or so. And probably if possible, just try to finish them before tomorrow's session. Okay. Anyways, I think, can you repeat once S1 minus S2? S1 minus S2 is like getting all the uncommon elements between S1 and S2. So if you look at the S1 and S2, you see that 30 and 40 is common between S1 and S2. What is uncommon? 10 and 20. So if you say S1 minus S2, take the uncommon elements from S1. And when you say S2 minus S1, take the uncommon elements from S2. That is what the difference between S2 and S1. Vishal, I think that answers your question, right? So that's it. That's a very simple one. Anyways, okay. Aniket, you are about to tell another feature of tuple. I already showed you that. Remember the example which I talked about last time, where we were returning all the operation result from a math operation function. So that's what I wanted to talk about. I mentioned that last time, like this is a kind of a unique feature with which you can return multiple values by converting them into a tuple. It's not like you are doing anything for that. Python is going to do all of this matching behind the scene. All you have to do is just coming back, and you're just going you're going to just return the values. By default they will get converted into tuple. Okay, exactly. Okay, Abhijit, yes, upload the recording as soon as possible. It takes at least an hour or two to get the recordings done, and after that it takes an hour or two to get it processed. So it takes at least 2 to 3 hours, I'm saying. So once it is there, I'll definitely upload you. Okay, not a big deal. Fine. So I think better we can. Parents are not provide the collection is considered as a tuple, but not as a list. Can we say that it's because tuple is immutable and the language recommended the mutable collection, so to consider the tuple in Python? Siddharth, exactly what I said earlier. So probably this exact same statement I mentioned earlier, because not only Python, all the languages by default recommend you to use immutable objects. If you are not specifying any parenthesis or square bracket, it is going to consider it as a tuple. That's exactly what I said earlier. So that your statement is absolutely right. Okay. Anyways, I think it's better we can take a leave right now. I'm going to take a leave right now. So better we'll see tomorrow. I guess again, thank you very much for attending today's session. I'll upload this PDF along with all the code on your WhatsApp, on your Git repository as well. And then we'll see. I'll see you tomorrow exactly at 8 o'clock in the morning. Okay. Thank you very much one more time. Have a very great day ahead. Bye-bye.